Assalamualaikum everyone. In today's video, we are going to dive into LeetCode problem, vowels of all substrings. This problem challenges us to calculate the sum of vowels in all possible substrings of a given word. So let's try to understand the problem statement. Given a string word, return the sum of numbers of vowels A, E, I, O, U in every substring of word. So our task is to find the sum of vowels in all possible substrings. We are given a word and we need to calculate the sum of vowels within each substring and return the total sum. Let's understand this with an example. We have example number 1. We have an input word and we have a string in it, A, B, A, and the output is 6. So all possible strings are A, B, A, B, A, and A. B has 0 vowels in it. A, B, A, and A have 1 vowel each. A, B, A has 2 vowels in it. Hence, the total sum of vowels is 0, 1, 1, 1, 1, 1, and 2. So the total sum is 6. Our output is 6. So its code is really very simple and easy. I have already solved it, and let's try to understand the solution. Okay, so we start by initializing the sum and length, in which we store the sum initialized with 0 and length and the length of words stored in n, and we can write it like this as well. Okay, so it's not necessary to mention in one line. Why we take this variable? Because it will keep track of total sum of vowels in all substrings, and the length hold the length of input word. And then we created a constant dictionary in which store all the vowels having value 1. Alright. And then we need to iterate each character in the word. So for iteration, we need a loop for I in range of length. That means the length of a word. Okay. Here we need to check that our character is a vowel or not. For that, for checking, we need if condition. Here we mentioned if word of I. Word, this word, A, word of I means for first iteration, it will be A. If A, it will check if A in dictionary. If A in dictionary, yes, we got the vowel word. So it will calculate the contribution of this vowel to the sum. And the contribution is calculated as length minus I, which is multiplied by I plus 1. Why we do that? Because this formula ensures that we count the vowel for all substrings it appears in. Okay, and we can see that how many times a character appear in different positions within all possible substrings. So here I plus 1 represents a count of a substring where the character is a starting point. Okay, just keep in mind that the concept of this formula, and the length minus 1 represents the count of substrings when the character is the ending point. So we need to multiply both factors where the character contribution of sum of vowels in the substrings, in all the substrings. I think it's a smartest way to account for the varying length and positions of substring. So finally we mention the return statement, and we return the total sum, which represents the sum of vowels in substrings. We can get our desired output, and it will check all the vowel words for each iteration of a substring. So for better understanding of this code, you guys should dry run this code, and you will see that if we apply this code in example number 1, example number 2, and the other test cases, it will pass all the test cases. Let's try to run it. Yes, it accepted all the test cases. Okay. If we talk about the both complexities of this code, for the time complexity, where the n is a length of input word, time complexity is O of n because we iterate one by one in a single word for character. And for the space complexity, as we took our dictionary, we use a fixed size dictionary. We have a constant dictionary. It's not varying as input varies. Okay, and a constant number of variables in that dictionary. So that's why the space complexity will be O of 1. Hope you understand this problem, and we have successfully solved this problem. Now you have clear understanding of how the code works and what is the approach behind it. So thanks for watching. Happy coding. I will see you in the next video.